the geometry of the dot product. Okay, by definition, the dot product with two vectors, let's say vector A and vector B, this angle theta is defined as A dot B is equal the magnitude of A times the magnitude of B and the cosine of the angle between A and B, by definition. Now, we see here that B dot A, from this definition, is B A cosine of theta. So, B dot A is equal A dot B. This is a scalar quantity. That's very important. These are a scalar quantity. Okay, that's the definition. Then we see some properties of the dot product between two vectors. Okay, here we see that B cosine theta is the projection of the vector V, okay, in the straight line, okay, in which A lies. Okay, that's a straight line here in which A lies. Now, this projection here, this one here, is just magnitude of B cosine of theta. So let's call this projection here as, let's put little u. Okay, okay, that's a small u. Okay, that's a scalar. This is a scalar. Okay, this is my u. Okay, that's a projection of vector B in vector A. Now, there is another property. Okay, A dot A, this is equal the magnitude of A times the magnitude of A times cosine of 0. No, because you have a vector A here and the vector A, okay? Vector A. So the angle between these two vectors, theta, is equal to 0 degrees. Cosine of 0 is 1. So A, vector A dot A, this is equal A squared. So from here, we can obtain the magnitude of the vector just the square root of A dot A. Okay, that's a very, very important property. And there's another one, is this. Okay, now from this figure here, suppose I called this length here, I call this as u. Okay, there's a vector u. Okay, you see, u is a scalar. Okay, this is vector u. Vector u has the same direction as vector A. The unit vector, okay, in this straight line over here, okay, in which the vector A lies, okay, we can write the unit vector EA is equal the vector A divided by its magnitude. Now, vector u is equal u times EA. Okay? You just look. Vector u is the magnitude of u times the unit vector, okay, in this direction. Now, what is u? Okay, the magnitude. This is b cosine theta. What is EA? Is vector A divided by A. Now, here I will multiply and divide by the magnitude of A. We can see here that B cosine theta times A, this is equal to A dot B. So A dot B is A times B cosine theta. Then it's left here. Let's put A squared, and this is A. You see? This is A squared because this here, okay, let's put here, okay, is A dot B. So it was left A, vector A in A squared. This I can write like A dot B. You see A squared is A dot A, and here is a vector A. See, that's how to express the vector, okay, the projected, this vector B projected in the straight line, okay, here is a vector U. So this is my U, okay. This is a scalar quantity. This is a scalar quantity. Scalar, this is a vector. So U has the same direction as vector A, okay? So from here, okay, we will summarize the properties, okay? That's the definition, okay? That's an important property here, and there's another property over here, okay? Property about the geometry of the dot product. Let's see some applications. Okay, consider these three vectors. I have vector A and vector B and vector C. Okay. Now, you see here that that's vector C. Vector A, you see, this is a resultant of the sum of B plus C. This is vector B plus vector C. Now, vector C, and let's put here in the middle, okay? Vector C, and here vector B. Okay. Now, vector C is equal A minus B, A minus vector B. Now, the dot product, the vector C and the vector C, this is C squared, then is equal A minus B dot A minus B. Okay, that's A minus B. C squared, okay, is A minus B, the vector A minus B, and dot A minus B. Let's expand this. This is equal A dot A dot A, plus, minus A dot B, A dot B. Now, minus A dot B plus B dot B, okay? Now, this is equal, this is A squared, okay? This is B squared, this is equal minus 2, look, A dot B. Let's write here, A dot B. This C squared, see, C squared is equal A squared plus B squared plus, this minus in this case, okay? Minus. The dot product taking these two vectors here is 2AB cosine of the angle. This is A and this is B. Let's call here alpha. This is cosine alpha. So this here is called a law of cosine. Let's put law of cosine. Okay? So this is a triangle, okay, with different length. Okay, magnitude of A is different. For instance, magnitude of C and magnitude of B. The C squared is equal A squared, the magnitude of A squared, plus magnitude of B squared, minus 2AB cosine of the angle between these two vectors here. That's the law of cosine. Okay? That's one of the applications of the dot product. Look, when you add, remember, and add two vectors, A and B, you remember this is my R, okay? My R, the resultant of these two vectors. Then you remember that you put here the angle alpha, and this is my angle alpha. So this angle here, I will call theta here. Let's go here, instead of alpha, let's put theta, okay? And that's what, you see I have A here, and I have B here, and C. Okay, let's call this a theta. Okay, now this is my angle between these two vectors. Okay, this is alpha and this is alpha. Okay, let's call here theta here. Okay, now what you did is A squared is equal A squared plus B squared plus 2AB cosine of alpha. But, okay, you see, now, attention this triangle over here, okay? Now I have, okay, I put, let's put here, this triangle, okay? Now here. I have this triangle over here. Okay. Now let's take a look at this triangle here. So this is R, okay? This is R. Let's use the law of cosine, okay? So R squared, forget here for a while, okay? R squared is equal A squared plus B squared, okay? This is B, this is A, okay? Minus 2AB cosine of theta, okay? Theta is the angle between these two vectors, okay? Look, this is A and this is A and this is B. This is B. Now, you see alpha plus theta is equal 180 degrees, okay? Now, theta here is greater than 90 degrees, okay? So if I use alpha, theta is equal 180 minus alpha. I'll plug this over here, okay? So R squared is equal A squared plus B squared minus 2AB cosine of 180 minus alpha. You see? So Cosine of 180 minus alpha, this is minus cosine of alpha. So r squared is equal a squared plus b squared plus 2ab cosine of alpha. You see, this is a law of cosine. The same thing, the same as there. You see, and here you have an angle that is less than 90 degrees. That's why I have minus here. And here we have the angle greater than 90 degrees. That's you put plus here. You see? So alpha plus theta is 180 degrees. Okay? Another application of dot products. I would say that's the most important application. Okay? When we use a standard basis or orthonormal basis like this. Like this. Okay. Here I put x1, x2, and x3. Instead of x, y, and z, I just write x1, x2, and x3. Then the unit vector on this x I call u1, and here let's put u2, and here e3. So size, the magnitude of e1 is equal magnitude of e2 is equal magnitude of e3 is equal 1. And also they are ortho. Ortho means they are perpendicular to each other. Okay? And normal because the magnitude of each unit vector is 1. See, now consider one vector A over here. Okay? I'll break it down into 3 components. Let's put here. This is a projection of the vector A on this plane, x1 and x2. Right here, I put e2 here. Now, this I can break down on this and this. Okay? This is my vector, okay? A2, E2, okay? Here is my vector A1, E1. And now on the x3 axis, you just take a parallel to this one. Okay, right here. Okay, parallel. Let's change here. Parallel here. Okay. This is my vector, the projection, A3, A3. Now, we can see here, okay, that this vector here, you see, let's look at this plane over here, okay? Look at this plane, okay? Now, this vector here, I can break it down in 2 vectors, okay? And this is A2, E2, A2, E2, plus here, A1, E1. Okay, E1, E1. Now, this vector here, okay, plus this one is equal to the resultant, which is vector A. So, vector A is equal, this vector over here, okay, lying on the plane x1, x2, is A1, E1 plus A2, E2 plus this vector here. So this vector here, you see, is over here. Okay? Now, plus this vector here is A3, E3. Now, since the magnitude of each vector is 1, we can write like this: E1 dot E2 is equal 0. E1, obviously, this is equal E2 times E1, which is equal 0. Now, E1 dot E3 is equal E3 dot E1 is equal 0. Now, E1 dot E2, equal E2 dot E2 is equal E3 dot E3 is equal 1. Why? Why? Suppose here's E1. The angle between E1 and E1, the angle is 0. So E1 dot E1 is equal size of E1, which is 1, okay, cosine of 0. Okay, this is 1, this is 1, this is 1, so that's 1. Likewise, E2 dot E2 is the size of E2 times the size of E2 times cosine of 0, which equals 1. So this is a very important result because we are using orthonormal basis. Okay, so a vector A can be breaking down into 3 components when we use a standard base or another basis. Okay, not only the standard base. For this is a very, very important basis because this is a peculiar, okay? This is a characteristic of the standard basis. So the unit vectors, the magnitude of unit vectors are 1, and also the dot product can be 1 or 0, okay? Then we used to write, okay, like this. We put here I dot EJ is equal. Look, now it's easy, okay? This will be 1 for I is equal J. This will be 0 for I different from J. Then I, J is equal 1 or 2 or 3. Okay, this is very interesting because when I is equal J, for instance, I is equal 1, this is 1, 1, this will be 1. Suppose I is 1, J is 2, this is 3, okay? Then EI dot E2 will be 0, okay? That's why different from J. A dot B, okay, A, okay, is breaking down in A1, E1 plus A2, E2 plus A3, E3 dot. Now B, vector B is B1, E1 plus B2, E2 plus B3, A3. So we have here, okay, 9 terms, okay? These will be 1, 2, 3, plus these 1, 2, 3, plus these 1, 2, 3. So we have 9 terms here. But you see, A1, E1 dot B1, E1. So E1 dot E1, you see, it will be 1. And then I can write here A1 B1 because these terms, okay, the dot with that term. U1 dot U1 will be 1. Okay? Then it will be A1 B1. Now, this here on this, okay? Now, E1 E1 dot B2 E2. So E1 dot E2 will be 0. Okay? Likewise, A1 E1 dot B3 E3, because E1 dot E3 is 0. So this is A1 B1. Now, let's consider this term here. Okay, look, A2 E2 dot B1 E1. So E2 dot E1 will be 0. Okay, now here, A2 E2 dot B2 E2. So E2 dot E2 will be 1. So this will be A2 B2. Okay, now A2 E2 dot B3 E3. So E2 dot E3 will be 0. So I got this. Now, A3 E3 dot B1 E1 will be 0 because E3 E1 is 0. Look at all is here. Now, A3 E3 dot B2 E2 will be also 0 because E3 dot E2 is 0. So this E3 dot E3 will be 1. So this A3 B3. This is scalar quantity. Okay, this is very, very, very important result. Okay, when we break down each vector into the standard basis. Okay, now I can write like this. Look, this is, I put a sum here. Okay, let's put I1, I was equal 1 to 3, AI, BI. Okay, now for I is equal 1, this A1, B1 is here. This is summation, okay, plus A2, B2 is here, plus A3, B3 is here. So